right. First one up there. Factoring. We got to remember how to factor. 1, 2, 3, 4. Two sets of parentheses. Then we do what? Split up the first term, x and x. Then we look at our signs. That a negative sign says our signs are going to be the same or opposites? Opposites. We're going to have opposite signs in this one. A positive and a negative. Okay? And then we need to know the factors of 10. Well, the factors of 10 are 1 and 10 or 2 and 5. Which set of these have opposite signs that would sum to a positive 3? 2 and 5. A positive 5 and a negative 2 add up to 3, right? Okay. So for this one, remember in Wheels' room, you had this and this. If you have a first term coefficient and both of these aren't perfect squares, which they're not, you multiply them. It's the AC method. So if we multiply them, we get a negative 28, correct? And the factors of negative 28 are 1 and 28, 2 and 14, 4 and 7, and that's it. Now, which of these combine to be a 3 in the middle? 4 and 7, right? So then what you do is you write 4x. Oh, what are the factors that would make it a positive 3? Positive 7 and negative 4, right? So we write 4x minus 4 and then 4x plus 7. And then take out the greatest common factor, what we can take out. Okay? So then this is x minus 1. No, I did that wrong. Because I'm mixing up Wheels' method and my method, and I screwed that up. Okay. I know Wheels goes 4 and 4, and so we need to have factors that so is this 28? Okay, now I got to remember Wheels' method. Because her AC method is different than the one I always used to teach. And then I had it down, and now all of a sudden, I forgot it. Any of you remember your algebra 2? Because you multiply these two, you get negative 28. And then I know she writes 4x and 4x. And then what does she do? Because I know my final answer is going to be 4x minus 1. And then x plus, nope, it's 4x plus 7. And then x minus 1. I know that's my final answer. So that's 4x minus 4. 4x plus 7. Yeah, I was doing it right at the start. I'm sorry. I keep second guessing myself all the time. All right, so it's 4x minus 4, and then 4x plus 7. Okay, you use these two with, instead of 4x squared, a 4x. Divide by the greatest common factor. And so you get x minus 1 and 4x plus 7. Okay, sorry about that. Sorry for confusing you. I was already there, and then I second guessed myself, and yeah. Okay, so that's how you do normal factoring, but what if we have sines and cosines in it? Then what do we do? Well, it's the same as what we did up above. We replace x squared with cosine squared. So it's just two sets of parentheses, cosine of x, plus and minus, and what and what? 5 and 2. Okay? Just the same as up above. I just replaced my x with a cosine. Okay? So, just like up above, if the first and last term are not perfect squares, then you multiply them together to be negative 28 sine squared of x, but don't even worry about the sine squared of x, negative 28. Where are the factors? 1 and 28, 2 and 14, 4 and 7. We use the bottom one. So it's 4 sine of x minus 4. 4 sine of x plus 7. Divide by 4, divide by 1. So it's sine of x minus 1. And 4 sine of x plus 7. If you would FOIL this, you're going to get this. Okay? That's factoring. So let's do a couple more. Sine squared of x minus cosine squared of x. That's called difference of squares. How do we factor difference of squares? Well, it's two sets of parentheses. What's the factor of the first term? Sine of x. Outers and inners are opposite. And then we go the last, cosine of x and cosine of x. Okay? Difference of squares make conjugate pairs. Okay? Because we want the middle terms to cancel. Now, here's one where we have a first term coefficient, just like we had first term coefficients up here. But if both the first term and the last term are perfect squares, like this is, then you only need to write one set of parentheses squared. Take the square root of the first term, the sine of the middle term, the square root of the last term. There you go. That's if the first and last term are perfect squares. Now, you should test this, and you can either write it twice in FOIL or take 2 times this to equal the middle term. Okay? But the first and last terms are perfect squares. It should wind up to be this. Now, this looks like a conjugate or a difference of squares, right? So we have tangent squared of x plus cotangent squared of x, and tangent squared of x minus cotangent squared of x. Okay? That's difference of squares factoring, plus and minus. But not so fast, my friends, because we're not quite done with this. What else can we do? We can factor some more, can't we? What can we factor more? Can we factor the first term? Nope, because that's sum of squares, and sum of squares does not factor. We're stuck there. Difference of squares, like this and this, does factor. So we're going to factor this more. How do we factor this? Well, that's tangent of x, plus and minus, cotangent of x, cotangent of x. Okay? Difference of squares. The next one looks pretty complicated. Any advice on this before we start the next one? Oh, Andrew Comas is all over this. Take out the greatest common factor. And what is the greatest common factor? Secant of x. If it appears in all of them, we can take it out. And now we got a normal cotangent squared of x minus cotangent of x. Cotangent, not cosine, Mr. Bishbach. And how does this factor? Well, it's cotangent of x, plus and minus. Factors of 6 are 1 and 6 or 2 and 3. Which one works to make a negative 1? Positive 2 and a negative 3. Okay? Positive 2 and negative 3. Last one. We have 4 terms. Is there a greatest common factor I can take out? No. How do we do 4 terms? Well, you group them. Group the first 2 and the last 2. Okay? Anything I can take out of the first 2? Oops, I wrote this wrong. There, now it's written right. I can take out a secant of x. And I get cosecant of x plus 4. What can I take out of the last 2? Cosecant of x. I get cosecant of x plus 4. If these match, they go in their own set of parentheses. But it's only to the first power. You don't square it. And then whatever is out in front goes in its own set of parentheses. So secant of x plus cosecant of x times cosecant of x plus 4. If you had FOIL it out, you'd get those 4 terms up top. Okay? So that's the basics of what we're doing today. 23 through 36 all on page 172. Only one assignment today, but I need to come around and check your 3-1s, the 5 assignments from section 3-1 today. So I will come around and do that now while you're working. Okay, so just when it comes to me coming around, I will stop by. You